Welcome to this session. My name is Shian Nafti. I'm a Google authorized trainer. In today's session, we're going to explore the Istio service mesh. The first thing we're going to do is download Istio. The version of Istio we're going to use in this demo is version 1.2.2. Next, we're going to enable access to the services which we're going to be using on the Google Cloud Platform. Let's move on to step number 3 and create the networks that will be used by our compute services. The first network is the Dual Control Plane Network 1. This is a custom network that will be used by the cluster running within Europe. Having created the network, we're now going to create a subnet for this network. In creating the subnet, we're going to assign an IP address range, which will be used by the resources provisioned within our Kubernetes cluster. Let's create the network for the cluster in the US. Let's assign a range of IP addresses to this network by creating a subnet. In the next step, we're going to create our Kubernetes cluster. But before we do that, let's take a look at the networks we've just configured. Let's navigate to the Google Cloud Console. Let's scroll down to the networking section and select VPC network. You can see here the two networks we created, Dual Control Plane Net 1 and Dual Control Plane Net 2. A subnet was created for the Dual Control Plane Net 1 network. The region for that subnet was specified as Europe. We also have another subnet created for the second network, the Dual Control Plane Net 2. This subnet was created in the US region. Let's return to the Cloud Shell console. In the next step, step number 4, we're going to create a Kubernetes cluster in Europe and in the US. Let's begin by creating the cluster in Europe. The cluster in Europe is a 3-node Kubernetes cluster with auto-scaling configured. Let's switch context to this cluster. Let's retrieve its credentials. And let's ensure that the current user has admin privileges against the cluster. Having created the first cluster in Europe, we're going to create a second cluster in the US. The US cluster will be a 2-node cluster with auto-scaling enabled. Let's switch context to this newly created cluster. Let's retrieve its credentials. And let's grant admin privileges to the current user to the cluster we've just created in the US. Before we move on to the next section, let's return to our Google Web Console and explore the cluster resources we've just configured. To do that, I'm going to navigate to the Compute section and select Clusters on the Kubernetes engine. You can see here the two clusters we created. We have a cluster Hipster DCP1 in Europe and the second cluster Hipster DCP2 in the US. The Europe cluster has 3 nodes and the cluster in the US has 2 nodes. Let's select one of these clusters to view its configuration. This is the Kubernetes version for the master, the endpoint for the API server. We have here confirmation of the size of the cluster, the location of the master and the nodes, the network currently assigned to this cluster and the subnet. And at the bottom, we have configuration information on the default pool. And here we have the auto-scaling configuration. Let's return to our Cloud Shell console. In the next step, step number 5, we're going to install our service mesh within these 2 clusters. Let's start with the cluster in Europe by switching context to the European cluster. Next, we're going to retrieve the credentials for the cluster in Europe. Having retrieved the credentials, we're going to create a namespace for our Istio system components. We're going to change into the directory where Istio was downloaded. Next, we're going to use the Helm template tool to create a custom YAML file, which will be applied in order to deploy Istio within the cluster. Having generated the customized YAML file, we're going to create a Kubernetes secret that enables access to the keys and certificates required for mutual TLS configuration. In the next step, we're going to configure 23 custom resource definitions. Let's check and ensure that 23 were configured. And finally, we're going to apply the custom YAML file in order to deploy Istio within this cluster. Let's repeat what we've just performed on the cluster in the US. We're going to start by switching context to the US cluster. Next, we're going to retrieve the credentials for the US cluster. We're then going to create the namespace for the Istio system components. Then change directory into the directory where Istio was downloaded. Generate the custom YAML file for installing Istio, which will be applied later. We're then going to create a Kubernetes secret for mutual TLS configuration. In the next step, we're going to configure 23 custom resource definitions. Let's ensure that 23 were actually configured. And finally, we're going to apply the custom YAML file we generated previously in order to configure Istio within this cluster. Let's return to the Google Cloud Web Console to explore the configuration we've just performed. Let's select the Workloads tab. Let's sort by cluster. You can see here the resources that have been configured within the cluster in Europe, as well as the resources configured within the cluster in the US. We have an identical set of resources within both clusters. The multi-cluster ingress configuration provides an additional microservice, the Istio core DNS service, for DNS resolution for services running outside of the cluster. Let's have a look at the Services tab. Let's sort by cluster. You can see a number of services. Services with a cluster IP are accessible only within the cluster. We have a service of the type load balancer, the Istio Ingress Gateway. This has a public IP address, and the Ingress Gateway provides a mechanism for services running within the cluster to be accessible from outside of the cluster. You can also see the services configured for the optional components we selected. Let's return to our Cloud Shell console and proceed to the next step, which is step number 6. In step number 6, we're going to create a config map that will enable kubedns to forward requests for DNS resolution relating to services running outside of the mesh to the core DNS service, the additional microservice that was deployed when we selected the Istio multi-cluster gateway configuration option. Let's switch context to the first cluster, that is the cluster in Europe. Let's retrieve its credentials. Let's create the config map and apply it to the cluster in Europe. The name of the config map is kubedns. We're applying this to the kube system namespace, and we're populating the global field with the IP address of the core DNS service. Let's apply this config map. Let's repeat this for the cluster in the US. Let's retrieve the credentials for the US cluster. Let's apply the config map on the US cluster. Before we move on to the next step, let's return to our Google Cloud Web Console and explore the configuration. I'm going to disable this so we can view system level configuration. Let's select the namespace kube system and type config map. You can see the two config maps here for DCP1 and DCP2. Let's select the config map for the cluster in Europe. And you can see the IP address for the core DNS service here. The IP address is 10.3.250.34. Let's check and make sure this is correct. Let's scroll down and locate the core DNS service. This is the core DNS service for cluster 1, and indeed the IP address is 10.3.250.34. Let's return to our Cloud Shell console. On step number 7, we're going to configure the application. But before we do that, let's have a look at the application configuration files. I'm going to switch to the web editor. I'm going to navigate to the project directory for this demo. Within the directory cluster 1, we have here the YAML files, which are going to be applied against cluster 1. In this deployment.yaml file, you can see the configuration for the services that will be deployed into cluster 1. You can also see here a service entries YAML file. The service entries YAML file has configuration for services that are running outside of the cluster. Let's take a look at the configuration for cluster 2. Here we have the deployments for cluster 2 and the service entry YAML file for cluster 2. An Istio default YAML file is also specified with a number of service entry configurations. There's a service entry configuration here for the currency provider, as well as the whitelisting configuration for egress. The services local YAML file has the configuration for all the services running within the cluster. Let's return to our Cloud Shell console. Let's proceed with the configuration of the application. Let's switch context to the cluster in Europe. Let's retrieve its credentials. Let's create an environment variable for the gateway IP for the first cluster. We're now going to switch context to the second cluster, the cluster in the US. We're going to retrieve its credentials. We're going to set a second environment variable to the second cluster's ingress gateway IP. Having set the environment variables for the gateway IPs, we're now in a position to proceed with the deployment of the application. Let's switch to the cluster in Europe. Let's retrieve its credentials. Let's customize the service entry YAML file for the cluster in Europe by specifying the correct gateway IP for the cluster in the US. Let's create a namespace for the application components. Let's label the namespace for automatic Istio proxy sidecar injection. To deploy the application into cluster 1, let's apply all of the YAML files in the cluster 1 working directory. Let's switch context to the cluster in the US. Let's retrieve its credentials. Let's customize the service entry YAML file to ensure that the IP address for the cluster in Europe is specified. Let's create a namespace for the application components in the US cluster. Let's label the namespace for automatic Istio proxy sidecar injection. Let's apply the YAML files located in the cluster 2 working directory in order to deploy the microservices in the US cluster. In the US cluster, a gateway configuration for the front-end microservice was applied, as well as a couple of virtual service configurations for the front-end microservice and front-end ingress. This is because the entry point for the retail store application is the front-end microservice, and this microservice is deployed within the US cluster. Let's return to our Google Cloud Web Console to explore the configuration for the application. We're going to navigate to the Workloads tab. Let's filter the cluster. We're going to start with the cluster in Europe. Let's select the namespace for the application. And you can see here the microservices that were deployed in the European cluster. We can also confirm the services that correspond to those 6 microservices. And here you can see the 6 services corresponding to those microservices. Let's have a look at the second cluster. Let's filter the namespace and select Hipster 2 for the second cluster. And here you can see the 4 microservices deployed within the second cluster. That is the cluster in the US. Let's click on the front-end microservice. On the overview page, you've got a dashboard displaying CPU, memory, and disk metrics. Also have a summary of the configuration for the deployment. Let's access the pod. Let's scroll down to confirm that the proxy was injected within the pod. Let's navigate to the Services tab. Let's filter the cluster. Let's select the namespace for the application. And here you can see the 4 services for the microservices deployed within the US cluster. We can also navigate to the object browser. Let's filter the configuration that will be displayed. I'm going to select App as well as all the Istio related configurations. Let's expand apps. Let's have a look at deployments. And here you can see all of the deployments on the platform. So let's have a look at the gateway configuration. Here is the YAML file. We can access the application using a wildcard, which is the IP address for the ingress. Let's return to the configuration. Let's have a look at the service entries. And here you can see the service entry configuration for all of the microservices. Let's have a look at the add service entry configuration. This configuration was applied to the US cluster. You can see that the host name has a .global extension. This means that the add service isn't running within the US cluster. And we have here the IP address of the cluster in Europe where the add service is running. Let's confirm that this indeed is the case. You can see the add service here. The add service is running in DCP1, which is the European cluster. Let's move on to the Services Ingress tab. And let's access the application to make sure everything was successfully configured. To access the application, we need to use the ingress gateway for the cluster where the front-end microservice is running, and that's the cluster in the US, DCP2. So let's click on the IP address for that cluster, and here you have the Hipster Shop application. We can select any of these items. We can modify the quantity, add to our shopping cart. We can buy more items. And when we're happy, we can place our orders. This concludes the Istio Dual Control Plane demo. I hope you found this useful. Thanks for watching and have a nice day.